We want AI to be safe, but a new paper warns its methods could empower censors. We'll explore how good intentions might create a censors toolkit. Let's get into it. Let's start with a featured paper. Position: The alignment community is unintentionally building a censors toolkit, by Sarah Ball and Phil Hackman from LMU Munich. This position paper raises a critical and timely ethical concern about the dual-use nature of AI alignment techniques, prompting essential discussion within the AI community about potential misuse for censorship and manipulation. Here's a full breakdown.
This table lays out the dual-use characteristics of different AI control methods, which is the core concern here. We're looking at how techniques designed for safety can also be repurposed for other means. Feeding into this, we can see how different alignment methods are categorized, from pre-training all the way to inference. A key area of focus is post-training alignment, which includes many of the techniques the community is actively developing today. Next, consider the implications for misuse, especially with inference time controls. The fact that these modifications are rated as easy to implement highlights a critical vulnerability that the community needs to address.
Up next, our second paper out of 3. TRAPSBench. Vision language models encode but fail to express epistemic restraint by New Pramono and Saurabh Kulkarni from Meta Superintelligence Labs. This work introduces a crucial benchmark and metric for evaluating epistemic restraint in vision language models, revealing a significant gap between internal model capabilities and their expressed uncertainty, which is vital for trustworthy AI. Let's break down its key contributions.
Our benchmark is built on pairs of videos, starting with a control video at the top where the full physical outcome is visible and the question is answerable. This is contrasted with a void video below, which is identical but gets truncated, making the question unanswerable because the final outcome isn't shown. To measure performance, we introduce the PEX score, defined by the formula at the bottom. A high score requires a model to not only be accurate on the control videos, but also to selectively abstain on the void videos, penalizing it for guessing. Next, we analyze the model's internal states to understand why it fails to abstain. Even though the VLM outputs a confident guess for the void video, our probing analysis shows that its internal representations actually distinguish that the outcome is unobservable. The Gemini 3.1 Pro models, especially the RL variant, demonstrate the highest PEX scores, reaching 0.568 in the guided setting, indicating strong performance in epistemic restraint. These models also show competitive accuracy, on par with GPT-5 Pro, which achieves 72% accuracy in the standard setting.
Up next, our third paper out of 3, FlashDrive. Flash Vision Language Action Inference for Autonomous Driving by Zakai Li and Jijin Liu from UC San Diego. FlashDrive offers a significant systems-level optimization for VLA models in autonomous driving, directly addressing the critical real-time computational bottleneck that hinders their practical adoption. Let's break down its key contributions.
First, looking at the top left, the VLA, or target model, processes a stream of images from the environment. It then generates a target hidden state, which efficiently reuses information from previous frames to understand the current scene without recomputing everything. Feeding into our drafter, we take that target hidden state from the main model, along with an initial set of mask tokens. Our deflash draft layer then uses a non-auto-regressive diffusion process to predict the entire action sequence, like slow down, all at once. Next, within these deflash draft layers, we use an adaptive caching technique during the denoising process. This allows the model to intelligently focus its computational effort on the most uncertain parts of the generated text, making the drafting process even more efficient. Finally, we apply system-level optimizations like CUDA graph compilation across this entire pipeline. These techniques fuse the computational steps together, minimizing overhead and further accelerating the whole process from image input to the final action output. The full set of optimizations, including quantization, substantially reduces the total latency from 716.9 milliseconds for AlphaMayo 1.5 to 151.4 milliseconds, while achieving a lower min-ADE1 trajectory error. This comes with a slight increase in min-ADE6 error compared to the baseline.
Those were the top papers. Now let's zoom out. ArXiv received 627 new computer science papers across 58 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: LLM reasoning, ethics and control, AI agents, behavior, trust, and design, efficient AI for diverse applications, foundational methods in computing and math, steering AI for human-centric outcomes. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries.
See you tomorrow.
Thank you to ArXiv for use of its open access interoperability.